What is Math World? Welcome back to Izzo Math. So today, again, I know you're thinking, what is O? So let's talk about what is O. Let's imagine that one day there was a boy who met a girl. Here's the girl. Okay? And the girl's name was Cosine. And the boy's name was Pythagoras. A there. Okay, so think of this as the Pythagorean Theorem meets the cosine function, and they get together and they make a baby. So the Pythagorean Theorem and the cosine function make a baby. This baby is named the Law of Cosines. Okay? And that's what we're going to do in this video. Let's talk about what is this baby that the Pythagorean Theorem and the cosine function made, called the Law of Cosines. Okay? So, first thing I need to do is draw a triangle. Let me do it here. This thing is not supposed to be a right triangle or anything. If it looks like it, I apologize. This is supposed to be a triangle. So we have a triangle. Let's call this side A, this side B, and this side C. And let's call the angle opposite side A, big A, the angle opposite side B, big B, and the angle opposite side C, big C. Okay? Now I want to put in here, that's going to be the height of the triangle. Let's call that H. Okay? So notice when I draw in the height that I get a little right angle here. And thus I can express that height H. Let's see. What can I say? The sine of angle big A, that is, I'm looking at this triangle here. Okay? And that triangle there, I'm going to say the sine of big A, because that is a right triangle. The sine of A equals H, let me keep the same color there, equals H over C. And that will give me an expression for H. H equals little c times the sine of big A. Okay? That gives me an expression for H. I also want to get an expression for this side here. Again, in this triangle. I want to get an expression for the bottom side there. So let's call that side, let's just call it S1. Okay? So I know that the cosine of A equals S1 over C. And so I can get that S1 equals C times the cosine of A. Okay? And now, since I know that this entire side is length B, I can get an expression for this piece. Okay? So that piece there, let's call it S2. Let's say that thing is S2, side 2. And again, since that whole side is B, and since the whole side is B, and this little piece of it is S1, which is C cosine alpha, or cosine A, I can get that S2 equals B minus S1, which means S2 equals B minus C times the cosine of A. Okay? So we have let me show you the triangle that I'm going to look at now. I'm going to look at this triangle here, this right triangle. Okay, so I'm going to pull that triangle out over here, and let's say, so I'm going to pull it out right here. There, there, and there. Where this side here is my S2, which is B minus C times the cosine of A. Oops. Times the cosine of A. And this side here is my side little a there. And this side here is H, but I'm going to rewrite it as we did down here. C times the sine of A. Okay? Now, let's use the Pythagorean Theorem on this triangle. And we are going to get, let's see, what do we have? That a squared, since a is the hypotenuse here, a is the hypotenuse, a squared equals b minus c times cosine a squared, so plus c sine a squared. And that is simply the Pythagorean theorem. This side squared plus that side squared equals the hypotenuse squared. Okay? So that's going to give me that a squared equals, now when I FOIL this piece out, we should have this down now. Anytime we have a minus b squared, it's going to equal a squared minus 2ab plus b squared. So that is, you square the first term, b squared, then you multiply the two terms together and double it, so minus 2bc cosine a, and then you square the last term, plus c squared cosine squared a. And now for this term, that's going to be plus c squared sine squared a. Okay, let's see if we can clean this up a little bit. So I have a squared equals b squared, so that takes care of that term. And now I want to look at where I have, so I have a c squared there and I have a c squared there, so I'm going to pull that out. So plus c squared times cosine squared a plus sine squared a. So that is, this whole term that I just wrote is c squared cosine squared a plus c squared sine squared a. Okay, and that leaves me with minus 2bc cosine a. Minus 2bc cosine a. Okay, and now you should know what that is. Cosine squared plus sine squared of the same angle. Cosine squared a plus sine squared a is a big fat 1. Okay? Sine squared plus cosine squared from our unit circle is 1. So we have here, this gives us the desired result that we're looking for, and that's going to be, let me put it in green here, a squared equals b squared plus c squared times 1 minus 2bc cosine of a. And that is the law of cosines. And I hope you agree now that this is the baby of the Pythagorean theorem and the cosine function. I also want to note that I didn't really have to start with this side a over here. I could have just as easily started with this side b, and we would have got that, we would have go through this whole process again, and you would get that b squared equals a squared plus c squared minus 2ac cosine of b. Note that this, the side always matches that opposite angle. So here's b, so here's B, here's that opposite angle. When we started with A, we got here's A, here's that opposite angle that's in the cosine on the other side. We also, if we would have started with C, we would have got C squared equals A squared plus B squared minus 2AB. And since I started with C, the side C, I get that opposite angle over there in the cosine, minus 2AB cosine of C. Okay? So here's our three expressions for the law of cosines. Start at any side, and you've got the Pythagorean theorem, and this so one side squared equals the sum of the other two squared, and then this 2AC cosine B there, 2AB cosine C, 2BC cosine A there, it kind of makes the adjustment for the fact that you actually don't have a right triangle. Okay, and note that if one of those, if it is a right triangle, that minus 2AC cosine of, if B was a right angle, then that would be the cosine of pi over 2, which is 0. So the whole thing would evaporate, and you'll just be left with the Pythagorean theorem. Okay? So let's leave it at that, and I'll try to work through a couple examples in the next video.